Nice. Okay, let me just close the chat. So the topic we'll be treating today is what's the force about DynamoDB Single Table Design. My name is Nwachukwu, or Chibuike Nwachukwu. I want to thank everyone for joining from across the world, right? I also Codementor for giving us the platform to actually meet ourselves. Okay, so a bit about me. I'm a software engineer. I currently work in Perix. Perix is a US-based company. We're into that we're a payment processing platform for payment facilitators. So we actually provide these facilitators with the infrastructure and the code they need to be payment facilitators, right? So we work in the embedded software space. In my free time, I also write articles. I believe writing is a way of sharing knowledge. Yeah, so I enjoy writing articles. I'll say both front end and back end. Sorry for the light change. Both front end, back end, and also a bit of DevOps. I'm also an AWS community builder. The platform is a way of supporting people who write Technical content about AWS, giving us, let me say, more exposure and more network in the AWS family. In my free time, I also, let me say, cook. So I love trying out new dishes. You can see some pictures of myself. Right, so let's get started. So this is how the talk will go. We have 4 sections we'll be treating. We have a QA section that will come at the end of the talk. If you have any questions, you can drop them in the chat and we'll address them once we reach the QA. So in section 1, we'll be giving a brief introduction to DynamoDB. We'll get to know what DynamoDB is, and how it came about. In section 2, we'll be seeing SQL challenges to scalability, right? So we'll come to understand the issues SQL faces when it tries to scale. In section 3, we'll go in depth into understanding what exactly is a single table design in DynamoDB. We'll see, we'll answer some of the questions that are popularly asked by people that are coming from an SQL background. In the last section, before the QA, we're designing a very, very basic architecture, a single table architecture, right, to understand how it actually works. So let's get started. What is DynamoDB? So before I go into the talk, I will drop this icebreaker. So why are we using a relational database for this? These workloads don't need the SQL level of complexity and transaction guarantees. So this comment was made by Swami. That was 2004 when he was still an intern. Currently now he's a VP of database, as you can see on my screen. But he made this comment when AWS was actually having challenges with their monolithic application. It was during the holiday period, if I'm correct, and the system was, let me say, was timing down or let me say, crashing because of the high demand, right? So they were currently building a monolithic application using an SQL database, right? Third-party SQL database. And they had actually stretched, let me say, the limits of SQL. They tested the limit of SQL and they actually saw, let me say, some faults in SQL that led to the crash. So while they were doing the analysis and investigating the error, Swami made this comment, and I'll say it bettered the DynamoDB, the move that began DynamoDB. So what is DynamoDB? DynamoDB is a fully managed NoSQL database system. Fully managed in the sense that Amazon, right, takes care of, let me say AWS, right, takes care of the whole orchestrator, scaling. So we just have to connect and just design our database properly, and we just connect. So it's serverless because we don't have to manage lots of the things that we would have managed if we were hosting a self-hosted SQL database. It's fast and predictable, right? Because we are not managing it, we don't have to worry about scalability. All right, so Amazon, with their team of engineers, worry about the scalability, and they're actually very good at that. So we can actually predict the performance, and that's like a good benchmark for any application. So the performance is consistent. It also auto scales, right? I remember when I think last week I'm currently working, we had an issue where we reached the limits we set for our DynamoDB, and once the second request came, DynamoDB has already auto scaled to meet up with the demands, which is actually a good feature. So we have primary keys, same way we have primary key in SQL database, but in DynamoDB is a bit different from how we understand SQL, right? So we have two kinds of primary keys, right? We have a partition, so a primary key that only involves a partition ID, right? So we'll get to know more about this later in the talk, but just know that this primary key always has a single partition ID that makes up the primary key. Then we have a second kind of primary key, which is a composite primary key that is made up of both a partition key and a sort key, right? So combining both of them gives up a single primary key. But in a real sense, there are actually two keys that we use to make up that particular primary key. We have indexes, two kinds of indexes again. We have the global secondary index and the local secondary index. We get to see it later in the talk, how it differs anyway from how we know indexes in SQL databases. So some differences between DynamoDB and SQL, which is like RDMS and RDBMS. There are actually lots of differences, but I just scaled it down to just these three, right? We are charged based on throughput. Compared to how we know SQL databases, for instance, MySQL, if we have like a platform or a platform that hosts our MySQL DBs, we are charged based on the data that is being stored, right? But in DynamoDB, we are charged based on number of throughputs. Now we can see throughput as the read and write capacity, right, of our application. So the amount of data we read and write is how we are charged. So it's a bit different from how you normally charge in a SQL DB. In a SQL DB, in our DBMS, data can be queried flexibly. So we can have multiple clauses, we can have select all, multiple join statements. So it's actually good for data flexibility, right? We can write multiple queries or a single query that can pull in data from multiple sources. It's good in the sense that it's flexible, but also very, very expensive because we have to pull from multiple sources, right? Make multiple network calls, which does not really scale well. DynamoDB, however, limits the way we can query, right? This makes it very, very efficient, right? Making very, very efficient because we're not making multiple calls here and there, right? So it's limited, but it's efficient. Exactly. So SQL challenges to scalability. So before we go into understanding how the challenges SQL faces when it comes to scalability, I just use the diagram to give a brief walkthrough of how SQL actually works. So I got this image from Alex Debris. Alex Debris is a data hero, AWS data hero. So I just plugged this image from his site because I feel it's the best way to explain, to best explain what I want to say. So we can see two tables. We have a customers table and we have an addresses table. So how SQL databases work normally is that we normalize data, right? So we have a customers, we have a columns customer ID, then a customer is linked to an address table using the primary key, which in the customers table is customer ID, and the addresses table is a foreign key as customer ID. So we can have a single select statement that just pulls where customer ID is 1, for instance, in address table, and it gives us 2 data. So that's how it actually works, right? So we normalize data. So as the database scales, we normalize and we add indexes, right? So if we observe that a particular column is getting more hits or more queries relies on that particular column, we index that particular column, which makes search or query search on that particular column faster, than when we didn't index it. So that's how it scales, right? If indexes tables, the more our data grows, and we observe a column is dragging back, we index the table. If there are more ways to normalize the data, we normalize the data. So if SQL handles scalability in this sense, so why does scaling problem occur? First of all, normalizing table requires multiple writes to save them. So we have a customers table, we have an address table. Perhaps we have an orders table. Now normalizing makes us segment data to multiple tables where they are, we can just identify a domain for that particular data. So a customers table, we know we're getting customers information from that table. Addresses table, we're getting address information from that table. So that is how normalization works. But because we have normalized our data in this sense, we have to write queries to actually put data in all these tables, right? And this calls for multiple writes to our DB. Right? Multiple writes to our DB is expensive, right? So we have to write, make multiple queries to save data in our DB. So data is spread multiple tables, and this also leads to complex query, right? After we save this data, we actually need to actually get them back. That is the concept of joins, right? So we use join statements, left join, inner join, outer join, to actually group our data back the form we need it. And these join statements are very, very expensive because we are going multiple times to multiple tables. We're making higher network calls to pull our data from various, locations they are stored. So join statements are very, very expensive. So scaling is a problem in SQL because we have normalized tables, separate tables. We have to save data in these tables, and we also have to get data back from these tables. Like I said initially, we have expensive join statements, right? So we have, take for instance, this query on our screen. We have select all from users, orders, and shipments. These are three tables which we have to get data from, right? Some have the misconception that if you put a limit, perhaps limit at 5, it only searches 5 data. But in real sense, it has to first of all go and get all the data before it cuts out 5 from them. So it still makes these expensive calls and pulls out data that we may not actually need at the end, right? Even if you add a limit statement. Then how then the SQL then handle this kind of expensive, growth of data, right? So we have vertical scaling and we have horizontal scaling. Horizontal scaling is when we keep on adding hardware resources, right? We can add CPU, we can add more RAMs, we can add more storage. That's particular single server. But why is the problem here is that there's a technology limit to a number of RAMs or storage a particular machine or device can have. So initially, we built a system that uses 6 gig RAM, for instance. And we keep on piling the RAM, to get to a point, I don't know if there is up to 10 terabytes for RAM, but where technology has not really reached, right? So that is the drawback of vertical scaling. You keep on piling, but you get to a point that you cannot actually go further in terms of technology. Then the concept of horizontal scaling, whereby we shard, right? We split, we have multiple machines that are split so that they can each handle the workload of our application. But horizontal scaling does not really work well with SQL, because if you remember, SQL database is built not really segmenting data, right? Data is just stored, normalizing data. We store in users table, we store in orders table, we store in shipments table, for instance. But we don't really specify that for users table, it should go into this particular machine. We just know our application stores it in our SQL databases. So it's a bit difficult to achieve horizontal scaling in SQL database. So most people actually move with vertical scaling. Vertical scaling has a benchmark, right? A limit to which you can go. So I'll be giving some brief examples of horizontal, let me say, scalability issues I've experienced. So I gave an instance of Amazon where they tested the limit of SQL and they had to rethink their design, right? The architecture of how they built their own internal applications, and which bettered DynamoDB. My own personal experience will be far back in 2019. We were building an application and we deployed it for a client, right? A SQL DB. And the client came to complain. So it was an e-learning platform, right? But we observed, so the client observed that at a particular time, when students are meant to take tests, there's a high demand on the application. So students delay their test to like the 11th hour. So they all rush to the system at the same time. So we have high demand on the system at a particular point in time, a very, very high peak. And that led to the system continuously crashing. Every time there's a test, perhaps every month, that same time it keeps on crashing. And we came in to look at the issue, right? And we observed that we needed to scale the DB, right? And we added more RAMs, requested for more RAMs from clients to add more RAMs. We increased the RAM. Everything worked well, right? But after some time, after months, we observed that the system crashed again because we had reached the limits. Let me say the RAM could actually carry the amount of load. So we have to go back internally and decided on what next to do. And we drew out a plan and we began to index columns that were on high demand, right? We observed queries and columns and we began to index these queries. But this actually took lots of our time, right? Because we had to sit back and it took months to really understand how the application worked, because we also had to normalize again the DB so that we have efficient performance. But we can't keep on doing, we can't continuously be doing this for applications that are in production, as ours was in production anyway, because it gives the engineering team more headache. And there will always be a limit of RAM, so we have to go back to normalizing data, which is very, very difficult because it can lead to data loss because you're normalizing data that is in production, which is a very, very big issue. So what is single table design, right, in DynamoDB? How does single table design, or how does DynamoDB using single table design address most of the issues we have seen in SQL? First of all, let's also understand what single table design is. The single table design simply means we're using a single table as a data source for application. Let me give a brief background, or let me use an example of SQL. So imagine we have a DB or an e-commerce application that only has a single table for both our users table initially, our orders table, our analytics table, our customers, products table, right? A single table handles, somehow, we don't really know how it works, but just handles, and we just make queries and we get our data. Not our data is got as we, let me see, gotten back as we put it, right? Not, it does not interact or cross, or users cross with others, right? It's gotten back well. So that's the concept of single table. A single table for our data source, right? So, but this calls for a radical shift of mindset, right? I'm going to give an example of what I mean by radical shift, because most engineers are coming from SQL databases where we have to normalize tables, like I said initially in this talk. And we know that as our data grows, we index. Our data grows, we have to also normalize further, right? But what do you then mean by bringing our data to a particular single table? And that's why we observe that when people actually use DynamoDB, they still build the application using this mindset. That's okay, we can actually create a customers table. If you see in this diagram, you can create an orders table, right? And they make two fetch requests, right? So because they want to achieve relation, right, in that SQL gave us freely, they want to achieve it in DynamoDB. I don't know if I mentioned this, DynamoDB does not have a join statement, right? They actually cut out that join statement because they actually saw the drawbacks of join statements. So because we want to achieve this join statement somehow in applications, we make two queries. So we go to the customers table, we get the customers data, we then go back to the orders table and say, okay, give us this particular order that belongs, sorry, orders that belong to the particular user ID. So we are defeating the purpose of DynamoDB because we want to achieve something that SQL does freely. So we make two queries to get a single data that we actually need. So I was giving a talk to, or let me say an onboarding to a colleague of mine, and he asked lots of questions, but I want to just drill it down to 2 questions. So his first question of why don't we have relations so we could join them? And why can't we make changes like to access pattern on the go? Meaning we have built our applications. If you remember in SQL databases, we can have an application running with the DB running, and we can just change the format key, go to the table structure, add a new, we can add unique keys, right? We can change the access patterns, right? On the go. But he was having conflict when I told him that we cannot actually do this in DynamoDB when our data is already on the go, right? Our data is already deployed, or already deployed our table. So I'm addressing most of his questions, or let me say the 2 questions. So like I said, for the first question, I think I've addressed it where I said, so why don't we have relationship? And then DynamoDB, when they were thinking about the database, right, AWS, my mistake, they saw that join statements were very, very expensive, and they took them out. So once they took them out, there has to be another alternative to actually work with relations for our applications. An icebreaker, I will just say, it has another quote. Okay, it's a quote from Alex Gabriel. He says, I got it from his blog. DynamoDB won't let you write a bad query that don't scale. Like I told you initially, DynamoDB limits our queries, right? So we don't have the flexibility in code to make queries that are very, very, very expensive. So it limits us to the access pattern that we have defined when we are architecting our database. This enables us to write good queries and avoid writing bad queries because we have thought about those queries on inception of our DB. So to answer his second question, you need to first understand that, like I said, DynamoDB calls us to architect a lot before we actually push our database to production, right? We have to sit down and understand exactly the access patterns our DB will use. So it defeats the purpose in the sense that we cannot finish architecting and we are changing on the go, right? Also, this could lead to issues with other teams. So imagine we have teams split out, and we know that DynamoDB does not really allow access pattern change. And let's just imagine that allows us to change the access patterns on the go. So a team is working with this particular access pattern, partition key, for this particular database, and team B, for instance, changes the access pattern. This could cause conflict among the teams because you don't really know what one has changed. The application will crash in production. Terrible. Like I said initially, it forces us to get our architecture right at the very beginning. So how DynamoDB solves this is the concept of pre-joins. So logically related data are kept together in a single partition. So each partition knows the data that it belongs to. So each data knows the partition it belongs to, right? So take for instance, the user's order example, we can keep all orders related to a user in a particular partition. So we know that once we hit this particular partition, this particular user, we'll get all his orders, his analytics, orders analytics, and perhaps logs with a single request. So that is the concept of single table design. We're making a single request, we're getting all our data. Like I said, you can drop your questions in on the chat, we'll address them in QA. So we're going to see how to design a very, very simple single table architecture. So the first point in designing a single table architecture is you need to understand how our data will communicate. So we use entity relationship diagrams to do this, whereby entities in our e-commerce could be the users, the orders. So we'll see how they interact. So knowing how they interact will give us an idea on how our application should work, right? On how, or the particular access patterns we should use. For the example I gave, I said find all the employees. So imagine we have like a HR application, right? How we know, perhaps we have an employees table, we have a contacts table, or we have an employers table, something like that. How knowing how each table or each entity in code interacts with themselves gives us an understanding on the access patterns that would possibly be called, or the possible access pattern that user will request. Take, for instance, we need to get all employees, right? Or we need to get employees by a particular ID. So an employee by an ID, we need to get an employee's phone number. These are access patterns that designing, we have to actually design from the ER diagram. We know the access pattern. From the access pattern, we then know the partition key to use, right? So I explained that partitions, DynamoDB's shards data, right? So it partitions data into various segments. So each partition key is the unique identifier for a particular partition. Then we have a composite primary key, which is made up of both the partition ID and the sort key, right? Both the partition ID and the sort key. We also have the concept of indexes, which are a bit different, or very different from what we know about indexes in SQL databases. So in SQL, we use indexes to, make queries faster. But in DynamoDB, we use indexes to add an extra access pattern. So if we add an index to a particular table, it gives us a copy of the base table. It creates a new copy of the table, and with that particular index, that particular access pattern, or that particular partition ID, that particular primary key, to access the data how we want it, right? So we can have either a GSI, which is the global secondary index, or an LSI, which is the local secondary index. But the main difference between both the GSI and the LSI is that a GSI is flexible, right? It's global. It allows us to have a new table with the partition ID separate from the base table partition ID. So we can look at each attribute in our DynamoDB. We want to query by a particular attribute that we don't have access pattern for. We create, and the attributes spread across all partitions, right? We can create a GSI for that particular attribute, giving it a new partition ID, right? The partition ID can be the attribute ID or the attribute. And if we want to add an optional sort key, we can use another attribute, or we can use the partition ID in our base table, right? But local secondary index is tied down to the particular partition. So we cannot create a new partition ID away from that particular partition. So what we can do is that we can create a new sort key, right? So we can use the partition ID and use the attributes we need as a sort key for this new table, right? This is mostly used when our data or the attributes we need is just tied down to a particular partition. It does not really spread out to all partitions. It's advisable to use GSI in most cases, because you may not know that an attribute will spread out till you're started working your application, right? You may not really know. So for an example, I designed a football DB, and I saw, first of all, I did an AR diagram to know how they interact. Then it gave me a concept of my access patterns for the football DB. So the few access patterns I have here is, I want to get all players from a certain club, right? I want to know, perhaps I'm a Chelsea fan, or I'm a Man U fan, I'm whatever club. I want to know all players from the particular Chelsea or particular Man U. But I also want to get a particular player's profile. Right? If you remember, Single Tabe Design allows us to make a single request to pull the data we need without making join statements, because in architecting a DB, we have pre-joined all the data we needed because we knew our access patterns. So I want to also get the club profile. So this is what I actually designed. Then I remembered, perhaps I want to get all players from a particular country. So that is where the concept of GSI comes in. I will then create a global secondary index on that particular attribute. So this then creates a copy of the table, but using maybe the country ID as the partition, and the partition ID in that new table. I can have partition ID as the only primary key, so it's not be a composite primary key, to be a single primary key. So this is like the basic example. If you look at the primary key, it's not given a name. I gave the generic name. as PK, because we could have club hash, the club name. It's not really tied down, right? Then the sort key is where I actually did some complex work, right? So before every hash statement, I have the identifier. So if it's a profile, I have a profile. If it's a player, I want to actually store. I give it the players, then hashtag player ID, which will be the player's number, jersey number, right? From this asset pattern, we can actually get, once we query with the partition key, club hash Real Madrid, we can get all players, then Real Madrid. We could also get the profile of the club Real Madrid, right? Exactly, the profile of the club Real Madrid when it's created, the club president. So like I said, we could create a GSI on the country Spain. So imagine if I want to know all players cut across our DB that come from Spain. They could be from club Liverpool, they could be from club Man U, they could be from club Barca, right? So I will need to create a GSI because club country obviously cut across multiple partitions in our DB. So I create a GSI and it copies table data with like the only attribute I actually needed, which is a club country attribute, and creates a partition key, which I obviously use. Partition key only will be the club country. I'm not sure I'll have a sort key because there's no need for that. I could use the player's ID, for instance, as a sort key. But the main point is that the club country, the partition key will be the club country, and it copies data from that particular table. So a few drawbacks to this, to using single table design. We have seen most of the advantages, but the major drawback is, like I said, it's a change in mindset, right? It's complex for people to understand because they're coming from a SQL database. It's also very, very difficult to change access patterns or the goal, right? So it calls for really understanding what application will do from the very beginning and calls for more time spent in architecting. And lastly, for data analytics, in SQL databases, we have tables that could be exported easily, right? But in DynamoDB single table design, it's a bit complex because we have a single database. So how do we do it? So we can fix this problem by relying on our application to split the data we need and customize it to the best way we need, right? So our application will handle pulling data and segmenting it so you can actually export it. So we've come to the end of this talk. Before I wrap up, just want to let you know that we're moving into QA. So you can drop your questions and we'll address it once I wrap up. So in summary, we learned about DynamoDB, what it is and why it came up. We also saw the drawbacks of SQL scaling or scaling SQL and how DynamoDB tried to solve it, or how DynamoDB addressed it. We got to know more about single table design in DynamoDB and address some of the questions that people might ask us. And lastly, we saw real-life examples of architecting with a single table design in DynamoDB. Additional resources, you can check out Alex Debris. He wrote a very, in fact, his blog has a wide range of ideas on DynamoDB, right? He also gave a talk for, I think, Amazon Invent 2020, which I also use as a reference to this talk, and the official DynamoDB documentation. Yeah, exactly. And the blog post that celebrated 10 years. Actually, DynamoDB was officially deployed 2012 to the public production. So this 10 years, so this last post, last resource was like a birthday post for DynamoDB. So you can drop in the comment section what you learned today. I actually want to know what people learned new today, because it actually helps me a lot and also helps our other listeners. We're moving to QA. So you can drop your chats. I will address them now, actually. So can I see? Okay, someone. Thank you. Nice. Thank you, Anthony. I'm not sure I can see the chat. Okay, can I see the chat without leaving screen. So do we have any questions? We'll drop them in the chat. Thank you, Marcelo, for listening to the talk. If you don't have any question, thank you, Simon. I would love to know what's new thing you learned. If I scroll down in chat, I remember Ranto. If you're still here, you said you want to learn more about data modeling with DynamoDB. I hope the talk has addressed most of your concerns. Yes, so I hope I get the name correctly. Iyenga asks if GSI are auto-replicated across all regions. So from my knowledge, I think they are replicated across all regions, because where I currently work, we have not really had issues with it not being available in a particular region. So I think it's replicated across multiple regions. I actually, for the sake of clarifications, do more research on that, just to understand that. I don't know if I addressed your question. Iyanga. So Carlos asked, do you have any kind of projects already made so I can practice? So I started learning more about DynamoDB 7 months ago when I joined my current place. So most of the projects I worked with DynamoDB Single Tabe Design has been internal projects. So I've not really had chance, except for an article I wrote and this talk, I've not really had a chance to create like a sample project. But hopefully, and if I have any chance for side projects, I will be using DynamoDB. If DynamoDB is the DB that will best suit the application. So I don't have any DB, any projects open source now that you can actually practice, Carlos. I hope with this talk and with articles and also the resources that I shared, you could, you know what, let me copy and post in the chat so anyone can, I'm not sure, can I copy? Let me see. So you could check out the resource. Let me see. Copy, let me paste it in the chat. Exactly. So you could, if you want to get more understanding on DynamoDB, you could look at the resources I referenced on the chat. All right. Once again, thank you everyone for coming. Have you ever, so Chris asked, have you ever had to redesign due to an access pattern that was not well defined? So like I said, most of the projects have been internal company projects, and we actually take great care not to make this kind of mistake Chris makes. But I've not really had to redesign. But I heard a story, right, when I joined, that they had to redesign a particular data on the go. So how they solved the problem was they redesigned the table and they had to use like let me call it a scraper or application to get data from the old table and somehow put it in a new table. So this is like the solution for transferring data from a single table to another single table, right? It's a poor design, it's poor, but that was like the only way they had. So I would say that is an idea of what I have on how to design or how to collect the data from the old table to the new table. Glad, Chris, I could answer that question. Do we have any more questions? I'll give him 1 more minute for that. Like I said, you could click on the resources to learn more about DynamoDB Single Tabe Design, and also DynamoDB, which is a great NoSQL database from Amazon. Say from AWS. Let me just say from AWS. Actually, Amazon. 1 more minute. Once again, thank you for joining. I would just go back to my slides since there's no other question. Okay. Go back to my slide. You can also drop what you learned new today anyway. Thank you for joining. Thank you for connecting. I'm so glad you could join. You can connect with me on LinkedIn, Chibuike Nwachukwu. I'm open to connections. And on Twitter, so I created this profile, I think 2 months ago, so I'm not really on Twitter. Well, I just created a profile. So you reach me mostly via LinkedIn, right? So also my GitHub handle is Chibuike07. You can see some of my projects, and you can actually just follow me. I can also follow you back, right? So thank you everyone for connecting. To have a nice day. Let me just one more check if there's any message in this chat. There's none. Okay. Thank you for connecting. Thank you for joining.